So I am so thrilled that I get to speak with Zhamak today about how things are going out in the world with decentralized data and data mesh, and some of her observations about the patterns as we talk to literally hundreds of customers over the last several months. So Zhamak, how are things?
Things are great. Great to be here and having this conversation, Cornelius.
There we go. So question, uh, data mesh seems hard to a lot of people. Why do you think that is? Why has it been this hard?
Yeah, you are right. In fact, you and I have talked to many organizations, a lot of them large, complex, significant organizations. And often a lot of our conversation starts with this sentence or version of this sentence told by the leader. We have chosen data mesh. We are doing a decentralized data strategy. We have made progress, but it's not exactly the full data mesh. Almost apologetically, they say that it's not the full vision, and we think that the reason is that the technology is not quite there yet. So I think it has been difficult, and I acknowledge that because the operating model that data mesh introduced was significantly different from everything else that we have done for decades. Sometimes we simplify kind of our understanding of data mesh to be, well, it's a decentralized domain-oriented data management, and that gets sometimes diluted to, we just need data products. But when you look at the hard parts of data mesh operating system, there were significant shifts that need to happen from what we were doing in the past to manage data, the full data supply chain, the full spectrum of data management, from ownership, processes, technology to what data mesh introduced, so that we could kind of get ahead of all the friction points that existed in the previous operating model.
Operating model. So that's a phrase that I hear you use a lot in our conversations. And I think you're describing sort of the existing operating model and where the gaps are. But what does that mean when you use that phrase? What are you referring to when you do operating model?
Sure. When I introduced data mesh, I used kind of different words to classify what is this about. One of those words were it's a socio-technical paradigm and approach. I think a more pragmatic, probably, language to use is operating model. And operating model simply is, the blueprint in how organizations deliver value to their stakeholders, to their customers. In this particular case, deliver value using their data. So that blueprint includes, the structure of the company, the processes, the team setup, the tools, the technology, the architecture, all of that combined to ultimately achieve the goals of the particular company using data and AI as a fundamental asset. So that's kind of a data operating, the scope of a data operating model.
So Shamak, tell me what you've observed. What are the changes people make? What's the big shift that you see out in the market?
So, if you go back to the status quo, the thing that with the operating model that was established for decades, the incumbent operating model, the data responsibilities were kind of centralized to a centralized data platform. And when we talk about data responsibility, we're talking about, all the activities that go to produce data in a way that is discoverable, governable, understandable, from ingestion to processing to storage to governance. All of that was centralized within a data team. So that was a very fundamental element of the kind of the pre-data mesh operating model. The type of work that the team was doing, or many of them are still doing, were around piping data, moving data from one location to transform it to another location. This concept of pipeline as, the industrial infrastructure of data pipelining was a very dominant and well-established architecture, and all the technologies around it were designed to pipe data, store data, and then layer it with some sort of a discovery or governance or catalog tool, as we call them. And ultimately, the way we were measuring value or measuring success was with how many terabytes of data we have now got under control. And we still lacked the kind of that ultimate goal, which is the lead time to go from data to value to make an impact to the business. So when data mesh came to the scene, that was the well-established operating model, and the changes and the shifts that needed to happen were the most fundamental shift was the organizational shift to move data ownership, soup to nuts, the whole data supply chain from, gathering the data to producing it to governing it to sharing it was pushed to domains, to business domains, so that people that know the data best and know the application of the best use data at the speed that particular business domain needs to move, not at the speed of the common denominator of the centralized data team. So that when we talk about domain-oriented decentralized ownership, was that across the dimension of organization and setup. Second, the concept of, the industrial kind of structure of how data was managed, data mesh shifted that and say, like, stop building pipelines and stop imagining, data work as pipelining and cataloging and governing. These are like very kind of processes that were ingrained into the previous operating model. And data mesh introduced this concept of well-encapsulated data product and say, well, let's just start with using data product as that unit of exchange of value, and let's build data products like share, discover, data products, right? Let's change what we are talking about here. And the governance piece had to be automated, computed, embedded into those data product, kind of creation supply chains, pushed to domains for enforcement. Governance piece could not be a centralized, again, kind of bottleneck. So the federated computational governance was another big piece of changing the operating model. And if you think about it, across organization, across the dimension of technology, across the dimension of architecture, across the dimension of governance, these are significant shifts. And it's hard. It's hard to make these significant shifts with the technology and processes and mindset and culture that was founded in a completely different operating model. And I think that's the kind of the root cause of the challenge that we've had so far, right? It's trying to force fit this new paradigm on top of foundational capabilities of organization that weren't designed for it. And ultimately what you get is that kind of productivity paradox, that hockey stick of, try to do something in a new way with your old technology and enabling pieces. Things get hairy and complex before you gain velocity toward the top of that hockey stick.
So, Zhamak, I know you've obviously worked with dozens of companies and leaders who've tried to implement this architecture and realize this vision of decentralized data. And I'm sure you've seen different patterns of implementation, this force fitting that you described, force fitting onto the existing operating model. And I know you've talked about three of them. Could you go through those for us?
I mean, let me just be clear. I have so much admiration and, really, admiration is the right word, for leaders that are taking this leap. I feel the job of setting the trajectory of industry on this decentralized, distributed, federated kind of model of data sharing, that is truly the only way to get the scale that we want. That job is done. Industry is moving in that direction. Now we are in the process of figuring out the house of technology, the house of processes. So I'm not criticizing these models. I think it's just a necessity of the phase we're in, right?
So, what are the patterns?
One of those patterns is a partial data mesh implementation. The second pattern, I call it open loop data mesh implementation, and the third one, proxy or shadow data mesh implementations. So the partial data mesh is, when you introduce often a new technology or new approach, people try to understand it with their own cognitive biases and with what they can control. And a collective cognitive bias of our organizations reduce data mesh from these four pillars to often a single pillar. So the four pillars of data mesh were, first and foremost, was around that distribution of workload in an end-to-end fashion, so that the end-to-end data supply chain can be pushed and distributed domain ownership. And the second was data as a product, and then leveling up the infrastructure, and so that we can have this data product oriented working was the third pillar, and the last pillar was the computational governance. What I see is this transformation has been reduced to kind of half of one of those pillars, which is data products, but a very anemic and basic definition of a data product that was available to people with the tools that they have. So this partial adoption is has reduced the data mesh to, well, if my teams can find data that has some metadata around it that defines what domain this data belongs to, and some annotations that says, if you need help, call X person. It's one, incremental improvement to not knowing where to even go to find data. So that's a partial. It's only half of the data as a product, and data as a product being defined as a curated set of data sets with metadata available to them, and perhaps some discovery or governance tool around it. The true decentralization, the true governance in a computational fashion, those pieces are still missing. And frankly, I feel responsible. I take some responsibility around that, and hence Nextdata, so that we can provide tools that make these abstract concepts and ideas real for people. For a long time, I think people were asking, okay, what is the computational governance? Despite concepts being written, because you can't really touch it. Unless you touch it, it's really hard to bring it to life. So that's the first one. I think we have incremental improvements from where we were, but we haven't gained that transformational velocity of true decentralization of distribution. The second one, at the moment, I'm calling it open loop data mesh, which is around kind of the idea of data mesh was about closing the loop between operational systems and analytical systems within a single domain, not across two giant, pillars of organizations. So within a single domain, you have a feedback loop between operational systems running the business, touching the customers, providing data, analytical data being produced, feeding the MLs or agents these days that are then serving the people and serving the customers. So that feedback loop. And what I see is really still a one-way. So data is still coming to centralized lake warehouse, and then downstream from it, some form of products being created. And that feedback loop within domains, or feedback loops within feedback loops, are not really implemented. So it's still a one-way data communication. People upstream are often is still not aware that there are, out of the applications and the data that is produced by running the application, there's actual data products being produced downstream that's still kind of not visible to them. So that's the open loop. We haven't been able to close the loop, and we haven't created these micro loops within domains, right? And then across domains. So it's not that you need to have one loop, but also you need to have a lot of micro loops, small loops. But the final one, which is an interesting one, which is probably the most widely spread model that I see. And again, these are not three independent models. You might have two of these or three of these. You might recognize all of these in your organization, right? People that are watching this. It's a proxy data mesh. So what has happened is that many of the data mesh or replatforming for decentralized data, we use different names to describe almost the same thing, start their journey from a data platform team, which is typically a centralized team, whether a centralized team in a large business unit or centralized team across the organization. And what happens is within that centralized team, which are very people that are data engineers, they're savvy with the existing data technology, they start formulating these domain-oriented shadow business teams within that, right? So they're trying to proxy the business domain inside the data platform team and kind of be the twin of, or the shadow of, the business team, and do kind of separation of responsibilities, but is still within a data platform team. And of course, naturally, the opposite side of it is that a lot of those business teams have their own little data teams, and they have the shadow data team inside the business, and they don't really talk to each other and are still fairly disconnected. There's a little bit of a power play also going on probably, but that's again, we didn't get to a point that the business domain teams, business units, they are empowered to end-to-end own their data, but they're empowered in a way that that data is interoperable and connected to the rest of the fabric of the organization, and slowly push that centralized responsibility, which is a massive, massive responsibility for a single team, to have to the domain team. So that's the third one.
Okay, so we covered three data mesh implementation patterns, or I should say prevalent anti-patterns. Um, so clearly we've got some ideas about what the new operating model should be and what we're going to do about that.
I'm an engineer at heart, software engineer at heart. So I see problems as kind of, I solve them with computing solutions or computer enabled solutions. To me, this is the solution to this goes back to the essence of computing, which is when things are hard and complex, what do? You shift the level of abstraction up. So if this data management inherently is complex, building pipelines, adding governance on top, measure quality, and all of these, and do that in a domain-oriented way, and do that many, many, many times in a consistent way, if that's the complexity, then the solution requires encapsulating that, leveling up the abstraction that we need to work with. So that to me is the key to any transformational change. And in this case, we would require a solution that levels up that abstraction, right? It creates that new abstraction, codifies it, builds a system around it, and people then can touch it, can use that new abstraction. So that's what's been keeping us busy for the last few years at Nextdata, to kind of define. And I have to preface this, right? This is not we're not pitching or selling Nextdata, but I have to preface that this conversation is under the influence of every moment of our time thinking about this problem, talking, working with a lot of organizations that are adopting this for real, and we had to find a solution. So in our case, that abstraction, the fundamental abstraction that we have built and introduced, is this idea of autonomous data products, which was frankly in the book. It just never had come alive. There was no implementation of it. So this new abstraction, there is a new abstraction we need to create to just differentiate between prior implementations of data products. I call it, as I call it in the book as well, kind of data products that autonomously can implement the soup to nuts of data management, short, aka autonomous data products.
So autonomous data products. This is a completely novel concept, and it's the heart of what makes what we're doing so different from the status quo. But it really implies such a different way of thinking.
I mean, if you, I am honestly, I'm struggling. I'm running out of tools to try to describe it. I think the only way is really to show it, and hopefully we get to show it very soon. But I think, in the book, I have put characteristics around it and I had defined it. So I'm going to use a different tactic today to describe it and define it with a set of provocations to say what it isn't. And I see, let's test this one out. So let's see if this is a better way for people to understand it. The way we got to this abstraction was through a set of challenges, challenging ourselves that if this abstraction existed, what we need to stop doing. If this abstraction exists, what if we stopped building data pipelines? What if we stopped cataloging data? What if we stopped granting access to data through storage layer? What if we stopped adding semantic layer? What if we stopped constantly changing data and copying it across for every single use case? For Gen AI, a different stack. For AI, different stack. For what if we stop doing all of this? And once we ask these questions, then we arrive at, okay, so then what is it that we start doing instead of those? And I think the answer would be, well, what if we just built autonomous data products that out of the box will give you all of these functionalities that today we have different processes, different people, different tools to implement them. So then we arrive at this concept of autonomous data products that are self-orchestrating, self-governing, self-defining their semantic. And these capabilities become the first class attributes of this new abstraction. And I know how kind of difficult it is to even grok this, because we are imagining an experience of this thing that, of course, we haven't seen the experience, we haven't touched it, we haven't seen it. So it's difficult, but also it's very difficult to kind of map the existing world and existing processes to it.
It's really such a different idea. Autonomous data products, they aren't data assets on storage. It's funny, even our metaphors for data are so static. We talk about files like files in a filing cabinet, but these sound like they're an abstraction that manages and fulfills promises, fulfills expectations, values, and eliminates, in addition, the need for many, many layers of scaffolding and band-aids that customers are currently having to wrestle with. It sounds like a servicification of data management.
Yes, that you're spot on. I mean, I'm talking about the whole data supply chain in a box, in a kind of abstraction. I'm talking about abstracting, encapsulating a lot of complex processes that are required to be done by multiple parties, so that you can have the files in your cabinet and an index to find the files in the cabinet, right? I'm talking about encapsulating all of that.
Okay, so autonomous data products are the encapsulated primitive of Nextdata OS. How do you put them to work?
So I know I'm talking kind of a little bit mathematically here, that mathematically, or from computer science perspective, let's describe these problems as a set of like first principle, first functions. Of course, there's systems behind it to show that in action. But from that simplistic view of the world, what we just did, we simplified a set of complex industrial age processes, cataloging data, ingesting data, to build data products, autonomous data products. But then it's not just build, right? You've got to now provide a set of tools to do primitive functions that can, of course, be compiled and composed into exciting functions, but primitive functions. What are those primitive functions? We need tools to build them, tools to run them, tools to find them, access them, right? Grant access and access, use them and control them, control their behavior. And this is this collection of operations that then we can perform on this primitive, now new abstraction. That's what we call a data mesh operating system. Just like an operating system that first encapsulates and abstracts a whole lot of movements on your hardware into a process, you have now a process, you can build applications through it or whatnot. And then you have a set of commands to build and run and monitor, same concept, hence the inspiration for the word data mesh operating system. So that's kind of what they can do with it, what people can do with it.
And I really love the categorization of Nextdata as an operating system, because it abstracts the underlying differences in services and infrastructure, but it also provides APIs that you can build all kinds of value on top of.
Yeah, and I think that the framing of an operating system, I know that the word OS and data OS and that kind of framing is not novel. We might have people might have arrived at it from different angles. I think the maybe differentiating angle that I'm taking here is that first and foremost, we've got to define the abstraction of the process. In our case, autonomous data products. We have to codify that, which for us is your whole gamut of data supply chain in a box with standard interfaces around it. And then then you have, as you said, the second piece is the abstraction of managing, different storage, different compute, because that is the layer that we are abstracting on top.
So, how does this fit into our customers' existing world? I mean, is it even possible to imagine doing this in a brownfield setting?
Yeah, I think it's a great question. And it's a question that often we get asked because anytime we are introducing in a market a new level of abstractions, there's a from world, which is as is, and there's a to world, to be. And real people are involved in making that transition. So from our perspective, in terms of what we have built, one thing that is really, really key is integration into the current stack. So if we are encapsulating, containerizing, abstracting your whole data supply chain, we need this construct needs to be able to easily integrate to the pieces of that supply chain that is now being abstracted. So again, because we use the computer nerd language of operating system, we call these things drivers. So we have a driver for storage and a driver for compute and a driver for security, so that you have, again, that layer of integration to allow you to integrate into the existing infrastructure. And I have to maybe just add a little clarification point. When we talk about abstraction, we don't talk about obfuscation. We're not trying to obfuscate the function of storage, which is read and write stored data, or obfuscate the function of compute, which is run this process. We are trying to encapsulate them and abstract the kind of management of it, or orchestration piece of it. So we expect the technologies that are reading and writing data will remain the same. The technologies that are processing data, whether it's a Spark or SQL or something else, that would remain. So that's just a little maybe sidebar clarification. So this driver layer for integration into the existing stack, that's just from technology perspective, that's necessary. And then the second piece of it is from the organizational perspective. People have a lot of data assets. They have thousands and thousands of pipelines. They have files. They have tables. They've got their data assets. How do they go from that world to this container-based data product, autonomous data product, ADP-based kind of world? And I think, again, getting inspirations from data operating systems, you've got to have a bootstrap. You have to have a bootloader and a boot instructions, and to be able to bootstrap this new world. And that's, again, something that we put a lot of energy into, to be able to bootstrap your V1 version of your data product containers from your existing assets, and then empower the people to, now that they have something automatically, they've got some new shiny new thing to work with. Now they can iterate over it. They can build it and augment it and run it and manage it. I think that bootstrapping is a key piece of this operating system capability.
So, I mean, we've seen this before in computer science, right? A new higher level of abstraction, yet another higher level of abstraction, unlocking new value, opening up to a larger cohort of users and use cases.
No, I think it should be my brand. Like, I mean, this is what data mesh was. Again, data mesh wasn't a new thing, right? We had seen decentralization with microservices and domain-oriented teams back in the 2000s, right? Now we had to bring that to data mesh, brought that to the world of data. It's the same thing. Every kind of big, probably momentums that we have seen in the progress of, I guess, application of technology in large enterprises have a notion of that. With cloud computing, I think that was a big one. Right now, we're going through one with Gen AI. It's very similar with cloud computing. We're seeing how that unpack, but let's go to the previous one, which was cloud computing. For cloud computing to become universally available to everyone, we started to think about our applications and our digital assets as cloud native software. And then we developed a whole bunch of standards around what does cloud native mean? What does zero architecture mean? And then created the operating system, the virtualization, the containerization, the orchestration underneath that to make that possible. With Unix operating system, the paradigm shift was from single computing, batch mode, single user computing, batch operations to multi-user interactive online operations, and that required standardizing, encapsulating the concept of the process, and then enabling the platform, the tooling, so that users could do different things with the process. So again, this is not a this is the patterns and paradigms. You are right. You have seen it. I have seen it. I'm sure the audience who would listen to this can come up with other examples that we have seen encapsulation of complexity as a key to a transformational change.
So I think everybody's asking themselves, what happens next?
Well, I think what happens next is I would love to give people that are interested the opportunity to go and touch it, play with it, break it, and evolve it, right? And evolve it. So it's really an invitation to folks to come and check this thing out.
Okay, so to be clear, what that means is you come to our nextdata.com website, you click on the button that says learn more or get access to our early experience program. Let us know who you are, and we'll get back to you and set something up if it makes sense.
It's an invitation. Yes. Thank you, Cornelius.